Right. What did I say? I mean, you can plot a graph based on electron gaining energy. Electron gaining energy related graph than in the nan sorry. Actually, group 17, Senate group 17, this one 16, Senate 16, this is 15. Position of nitrogen is a little bit different from phosphorus. Okay, this is 14, this one 12, group 1. Okay, this one 13. This is the order found. All these elements are exothermic. Electron emits during the process. Emission occurs. Above the line, this element shows some kind of positive value. Helium, neon, argon, the values are little bit higher compared to other, right? Nitrogen is found very closer to 0, mean around plus 30 value, plus 30, that is the answer for the nitrogen, electron gaining energy, right? So I think we understood. This kind of pattern you can see in most of the group in the pattern that patterns telling some message. What is that pattern, right? I may take some question in the future even relate to this kind of work. Okay, up in the pattern, okay, I think this particular pattern, right, the pattern deviate. Second, you can clearly see the second period element only shows some kind of deviation from rest of the elements. அதுக்கு the reason இதெல்லாம் நாங்க முன்னால பார்ப்போம். We'll try to discuss those things later on. So, right, you can cancel these two and you have three options. அதுல sulfur shows little bit higher emission when electron is gained. So it is very clear from the graph. You can select the answer. Now, discuss which of the following statement is true regarding the positive rays. So, right, is not that much not difficult. Which have been detected during the experiments with the discharge tube in determining atomic structure. Okay, they are found together with the cathode rays and responsible for the glow observed in the region behind the perforated cathode. Actually, yes, the both rays, cathode rays and positive rays, found together. When you put a hole in the cathode, then only they observed the things very clearly. Sometimes the condition applied may be a little bit different compared to cathode experiment. When they're doing the canal rays experiment, they may use little different conditions, right? When you put a hole in the cathodes, they observe clearly some rays behind the cathode. Okay, that statement is correct. Statement is correct. These rays consist of particles whose mass is independent. It's totally wrong. Depends, isn't it? Positive rays are due to gaseous particle. What is found in the cathode ray, isn't it? Gaseous particle. Because of ionization of these positive particle, it will go toward the cathode. Why? These are positive, no? These positive rays. These positive rays go toward the negative plate. That is how the positive rays develops. So dependent, not independent. It is wrong. So answer B is wrong actually. Further, this is the diagram I have included to the slide. You can see this one is the cathode ray, isn't it? Cathode ray. This one rays, positive rays. Positive rays. We call canal rays or positive rays. These are electrons. This can be different, isn't it? Depends on the gas inside the tube. It is different. Mass and everything is different. It is very clear for us. They are formed by loss of electrons. They are formed by loss of electrons from the atoms or molecules. Yes, definitely, right? Because of this only the one ion, right? Na plus ion. Further, if it strike by the electron or high energy due to high energy, isn't it? It may strike by the electrons, cathode ray, or it can excite it, right? It is not possible for the sodium-like element. But nitrogen, some other elements can lose more electrons in it. it can lose more electrons. So they are formed by loss of electrons, right? From atoms or molecules, no problem, right? Okay. Atoms or molecules. What they mention here is we can analyze. For example, I told you N2 molecule is here, right? This is a molecule. When it strike by cathode rays, right? It may split it to atoms. Once again, this cathode ray strike, then it will become ions, isn't it? Ions are but in the molecular state, even when it strike the atoms, may lose the electron and make a molecular level ions can form. So atoms or molecule is possible. Yeah. They are not affected, right? It is wrong, isn't it? It will affect by the electric and magnetic field. So answer is BC. BC you may mark, that is second answer, right? AB, BC, CD, and AD. I don't know how do you mark. BC is the correct answer.
Excuse me, sir.
Oh.
Sir, can you say an example for an ion which is created from a direct molecule after the striking of the cathode ray?
Right. That is the thing I explained to you here. I mean, for example, nitrogen, oxygen, right? N2 molecule we have taken inside the tube. Okay. If it strike the bonds, right? If it strike the bond, there is a possibility of atomization. Atomization can occur, right? Atomization can occur. Not only electron beams colloiding, even high energy applied also sometime it may break the bonds, right? It may break the bonds. And further, if it strike high energy will produce the right atoms will become a what? Ions. Furthermore, right, for into molecule, if it strike these are valence electrons available, right? If it have high energy, I mean, if it strike by an electron or if it gained by this, you are applying high energy, and the high energy apply pannakoda, sometimes these valence electron may jump, and it may create a positive charge here. By lose of electron, N2 molecule bonds break just this nitrogen atom lost the electron, so it will become N2 plus now, right? That is how the positive charges can come in the molecule, right? Okay, I think you understood the point. Now, we'll try to go to the next question. The question number maybe, right? Already we have discussed the question number 10. This should be 11, right? Question number 11. Okay. Which of the following statements is not true regarding subatomic particles, right? Okay, it is very familiar for us. Electrons show both wave properties and particle property. Okay, same time actually, right? When it shows the particle property and right same time it also having a wave property. So yes, that is correct. You have to find not true, isn't it? Electrons in an atom are dispersed in three-dimensional region of space around the nucleus, reflected to as orbitals. Actually, the concept of orbitals, isn't it? This is a nucleus. Electron can locate in any place around the atom, right? You can locate. Mean if you started to find out where the electron is, it can be found in any place in the three-dimensional area, right? The maximum probability of finding an electron, around the nucleus is the orbital, isn't it? So rather than revolving in the track, that concept is outdated, not accepted. In the particular region, the position of electron can be seen, right? Here in case of s orbital, spherical shape where the electrons are moving here and there. It represents the two electron. A movement of two electron can be shown in this way, right? So that is the concept of orbitals. I think you may understood. The third answer, 1, 2, 3, right? This should be 4, this should be 5, right? The neutron was detected. Neutron was detected when beryllium was bombarded. Yes, it is true. Chadwick's experiment, I think you may know that Chadwick the experiments are on the beryllium sheet alpha rays. No, they mentioned cathode rays. It is true. Right, bombarded with the alpha rays, accelerate alpha rays, then you don't see anything. Then if you put a wax here, wax, it is made up of carbon. Now it produces certain rays, isn't it? Right, that indicated some kind of detection. Geiger counter and Shulunanga, right? Ion detector undu shows dumb turnings. So initially it didn't show, do not show any kind of things, right? Right, if it is found in this way, sorry, in the initial state, detected didn't show anything, isn't it? In this way. Okay, actually, this is an ionic detector. Geiger counter and Shulon. Ionic detector. Whenever the ions are collide, strike the surface, it will show some kind of movement. Right? They didn't see anything. Then they place a wax in front of the detector between the beryllium sheet and detector. So later on, it shows some detection. So they understood some kind of rays has to be developed here, which are not charged, right? Those chargeless particle, when it strike the nucleus of wax carbon atoms, it produces proton. That proton is reason for this kind of movement. Okay, I think you may understood. So this is the fourth answer, cathode ray alpha rays. The neutron is an uncharged particles, yes, with its mass approximately, yes, approximately equal to that of proton. Remember that mass of neutron is higher than proton, slightly higher compared to proton. So they mention approximately, yes, this is correct. The number of proton in isotope an element are same each other. Yes, definitely is a unique number. That is how the mostly identified and we use nowadays for a atomic number. As atomic number, proton numbers are used as atomic number. It is unique one. So the answer is third one. Fourth one. Now let's go to the next question. Okay, already we have discussed 11th one. Now we have to move to the 12th question. 12th one. Okay, the correct decreasing order of the ionic radii of these ions. Actually, you see this one to 8. To 8, isn't it? To 8. We call isoelectronic, isn't it? Isoelectronic configuration wise, everything is okay, same configuration. When you comparing the radii, right, where it is very clear, cations are smaller, cations are correct decreasing order. They are asking order, you have to find the order. Cations smaller compared to anions. So the size, if you compare these two, these three, smaller size, isn't it? Smaller size. Here 13 proton, right? Here 12 protons, then 11 protons. So this one, 13 attract more powerfully the 10 electron compared to other two, isn't it? So you have to find the decreasing order, right? So decreasing order, Al3 plus smaller compared to magnesium 2 plus, right? Other big one, you can think about sodium, decreasing order. Now we have to think about F minus and O2 minus, right? It is very clear. Here also configuration 8 to 8. Here, how many? Right? So here 7 proton. Here, right? 7 proton. Yeah, fluorine 7. 9 protons. 9 here, 8 proton. Yes, it is very clear. 8 proton has to attract 10, 9 proton will attract 10. So this one difficult, isn't it? It will become a big one, right? About the 9, 10 attract பண்ணதை விட 8, 10 attract பண்ணுறது difficult. Therefore, O2 minus. Other way, write the simple way. But okay, 2 minus வந்தாவே என்ன செய்யறது? Electron cloud big one ஆகியாச்சு, isn't it? So this is the order. I think you may have document with you, right? AL3 plus, Mg2 plus, Na plus, F2 minus. So the third is the answer. Correct answer is third one. Right. Let's go to the question. Next question. A sample of hydrogen atoms excited in a flame has the electrons distributed in n is equal to 2. Next 1, 2, 3, and 4. Yeah, you have a sample of hydrogen atoms excited in a flame as electrons distributed in n is equal to 1, 2, 3, and 4 energy levels. How many different wavelengths of radiations are emitted by the same sample according to the Bohr theory? Actually, what can you do here? You have to draw 4 energy levels, isn't it? 4 energy levels can be drawn, isn't it? 1, 2, 3, and 4. 1, 2, 3, 4. Say this is alignment. There is a possibility of 3 lines, isn't it? There is a possibility of 3 lines. And some electron may come from 3 to 2, isn't it? In 1, 2, 3, 4, 5. Furthermore, from 4 to 3, right, another electron is transition is possible, 6. Then altogether 6 is the answer, right? I think, yeah, 6, 1 is the correct answer. I think you may understood that work. Now, 14th one, the arrangement of electron pairs around SB atom, atomic number is provided. Actually, you have to familiarize. Sometimes they will provide the periodic table. You don't need to worry. If it is not given, remember, so right after inorganic chemistry, you may able to find the proper place for the element, right? Nitrogen, phosphorus, arsenic, Sb, bismuth, antimony, bismuth. Antimony is the element which group belongs to group 15. 15 குறிய element Sb. Valency வந்து 5. Valency 5, isn't it? Valency 5. 5 is the valency, okay? Right. Valency is 5. Okay. How are you going to count it? Sp, 5 electron donates. From fluorine, another 5 electron, 10. But because of negative charge 2, together 12 electrons are there around the S antimony element in the valence shell. There are 12 electrons. So if you divide by 2, you'll be able to find the electron pair geometry. That is the question part, isn't it? The arrangement of electron pairs. Yeah, that is we call electron pair geometry. So if it is 6, the electron pair geometry is octahedral. So that is the answer. Question number 15. What is that? Wavelength of red light is 700 nanometer. Calculate the energy of 1 mole photon of this radiation. I think you may done it and check the answers. One thing I had to remember here is generally they may provide phase number one. Sometimes you can do this kind of calculation, but the time issue is the problem. Time you may take a lot of time, so you had to overcome that issue by practicing different techniques. The work solve panna paakkanum. Okay, I'll try to explain this issue. First, try to look at the board answers, right? This is not equal to this one, isn't it? Here 100. Okay, 3 zeros are there, mean 100, 0 point something, 100. These are right. Either right. very clear cut 10 to the powers 171 10 to the power minus 3 here, isn't it? Here 0 means 10 no powers, right? In this way, we had to little bit observe the answers, then we can come to some work, right? We'll try to find the answer now. Initially, we know C is equal to n lambda. We had to find first the frequency C, right? C over n, right? 3 into 10 to the power 8 meter per second. And okay, lambda, isn't it? Right? We had to find the, not lambda, isn't it? We had to find the frequency, isn't it? Frequency the find panel lambda should be marked in this way, isn't it? N is equal to C over lambda, right? 700 into 10 to the power minus 9 meter. So if you solve this 3 over 700 10 to the power mean 70. Just try to apply in the second stage. E is equal to H nu is the equation to find the energy of photon. Adala 1 mole in the word is mentioned, therefore we have to multiply even L. H approximate value can be added 6.6 10 to the power minus 34 joule second into 3 over 700 10 to the power 17, isn't it? Furthermore, 6.6 into 10 to the power 23. In this way, you can mark so data, isn't it? If you bring all this data, 6.6 into 3 into here 6 divided by 7 and 700 இருக்குது. 3470, you know that minus 17, 10 to the power minus 17, and 10 to the power 23 is remains. The other names 2 zeros available, so if you cut this one, become 21. So difference is 10 to the power 4, clear, right? If some kind of approximation you can do, very careful, you can do this. Now just you try to cut these two, right? Same in the cut real answer. Real the 6 over 7, 0 point something, 0.8 equal initially cut real answer little bit higher. 6 7 cut same. Then 7 cut I will try to cut it and I try to multiply 8 19.8 in வருது. 19.8 in வருது. உண்மை real value little bit higher than I சொன்னேன். Mean the value would lesser value icon. Now we'll try to fix this issue. 198 into 10 to the power 3. Now the answer is 198 kilojoule வருது. Kilojoule actually answer. So in the answer, real answer should be little bit lesser than this value. So only answer matching with that one is this one, isn't it? In this way, you may do some approximation very carefully. You had to do, right, reasonable work, right? If in the 7 போட்டதால கொஞ்சம் அந்த value கூட வரும். Yes, it is really in that way. Real value has to be a little bit lesser compared to this one. So in this way, you can find the work. Right, I think you may understood the work. Answer is 171. Now, the question number 16. Which out of following shows the correct decreasing order of electronegativity of nitrogen? Electronegativity, what are the things we had to consider? I think you may have some idea. First, you had to find the hybridization. Hybridization has to be considered. Second, oxidation number, right? And charge, formal charge. In this way, you can find the things. There are some other factors also there. This is the order, right? Now let's find the things. Ammonia is -3, right? Hybridation you will try to consider. Right here in these three cases, hybridation is same, sp3, right? I think you may find out that when you come to NO2 plus, right? This is the arrangement of NO2 plus. You have only 2 sigma bonds. Therefore, the hybridation is sp. Sp is the hybridation. So decreasing order of electron mean, right? You can, I think you may know that electronegativity for its character is higher here. Therefore, its electronegativity is higher, right? NO2 plus should be high, show higher value. Answer should be this, so this, right? This cannot be the answer, right? Now, right, when you come to these three, it shows same kind of hybridation. Then what it governs, right? Second one, oxidation number also -3, right? I think you can check it. In all these cases, oxidation numbers are same, right? I don't know whether we have difficulties to find the oxidation number. If there is a difficulty, you have to ask. Up in the oxidation number same, hybridation is same. Then you can go for a formal charge. What is the formal charge? How it governs? Plus more electronegative, 0 neutral, and minus less electronegative. In that way, you can think about the issue. So answer is 2. The fourth answer is wrong. I think you may got the correct idea. Now, right, the statement questions are there. Chemical properties of isotopes are similar. Yes, configuration same, electron configuration is same. That is correct. Mean chemical properties depends on electron configuration. Though these are same. Yes, correct. Isotopes have the same number of protons but different number of neutrons, right? Yes, that's also correct, right? Not matching. The real reason is I told you same electron configuration. That should be the reason, right? Electron mean configuration only changes the mean chemical property. So answer is second one for this one, right? When you come to question number 18, ICl2 and NO2 plus, right? In question, quick draw pandra abilities in develop NO2 plus this one, it is linear. ICl2 minus, yes, quick parkers in practice one iodine 7, send a chlorine, there are 2 chlorine and -1, altogether 10. 10 mean divide panina, it will become 5. 5 electron pair geometry is trigonal bipyramidal, but you only do have a 2 chlorine. Other 3 are lone pairs. That also linear. So answer is correct. Answer is correct. I don't know you may able to do these things, right? I think you may practice. Molecule science that have the same number of repulsive units. What do you mean repulsive unit? Repulsive units is lone pair plus bonding pair. Isn't it? That is we call repulsive units. Okay, same number of repulsive units generally have the same shape. Okay, bonding pair only decide the molecular shape, isn't it? Right? Lone pair, bonding pair, which according to bonding pair, we mean arrange the shape of the molecule. So you have to remember that it is very clear. It cannot be correct, isn't it? Right? Why? If it's a certain one, it is okay, but most of the case we can't see in the right. For example, CH4, NH3, H2O, isn't it? To consider all these cases, repulsive units are same. Here tetrahedral is a shape. Here pyramidal shape. This one angular. This way there is lot of difference available. So generally in the term also not matching with these things. So answer is third one. Okay. Next question number 19. Only we have 80 minutes. Polarizability of seal minus sign is greater than that of what? Yeah, it's very clear. Real minus big one, isn't it? Easily distorted by cations. So this fluorine, this one chlorine. Bigger size will distort highly compared to smaller size. So this answer is correct. Polarizability is higher for chlorine. Nuclear charge of chlorine is higher than that of fluorine. That's also correct. This is right. This particular phenomenon is due to mean size of the electron cloud. That is the reason here. Right, same charge. Size is the reason. So nothing to do with these nuclear charges. So both are correct. Second answer, no connection with first one. The final one, last one, is important thing. Try to remember the properties of one pH bond. I think pH 3, when it react with boron, it form a, what is that? pH 4 minus sign. This is what it called trigonal structure. When it come in this way, boron, it become a tetrahedral shape. There is a minus charge in the boron atom. Net charge is minus. After it forms a dative bond, I think here the dative bond involves. After it forms a dative bond, you can't separately identify a certain dative bond, right? You can't separately identify. The properties of one BH bond in the BH ion is different, right? You can't see such a difference from those of the other three bonds under it. It is wrong, right? One BH bond in the BH4 ion can be identified, cannot be, right? Can be, that is wrong. So fifth is the answer. I think you may got it. This particular last question is found in the past paper. Old past paper on the concept which I have taken. Yes, you can do it and check it, that answers. If you have any difficulties, you can chat with me. I mean, WhatsApp discuss pannunga. If there is any changes or things, if you won't understand, we can explain. Okay, right. Let's wind up the program, right? Assalamu alaikum.